Imagine we're writing rules for a bouncer at the Krusty Krab nightclub. Instead of jumping straight into if-elif, we first write a tiny rule chart. That's basically what a decision table is. Here's a simple version. Don't worry about code yet. Rule 1. Age less than 18. Action, no entry. Rule 2. Age between 18 and 20. Action, entry, no drinks. Rule 3. Age 21 or more. Action, entry plus drinks. Each line is one rule. Later, each rule will become one if or elif branch. Goal for this lesson in simple words. 1. Take a tiny table like that and turn each line into clear if, elif, else in Python. 2. Make sure only one rule can fire at a time, no overlaps. And every possible age has some rule, no gaps. Quick check for you. For age 17, which rule above should fire? You can just answer Rule 1, Rule 2, or Rule 3. Love that you asked to loop back. Think of a decision table like a tiny organized roll sheet you'd tape next to a register at the Krusty Krab. Story version first. At the stand, Squidward needs to decide what to say based on a customer's age and money. If they're under 18 and have less than $10, sorry kid, come back later. If they're under 18 and have $10 or more, you can buy a small meal. If they're 18 or older, you can buy a full meal. Instead of writing these in a paragraph, we put them in a small table. Now the idea. A decision table is a grid that shows conditions, like age, money, and actions, what to do, with each row equals one rule. Very simple version, text format. Row 1, age less than 18, money less than 10, say come back later. Row 2, age less than 18, money equals 10, say small meal. Row 3, age equals 18, say full meal. Later, each row will turn into an if, elif, else. Does this rule sheet next to the register picture make sense so far? If yes, I'll show you a tiny 3-row table and we'll map row 1 into Python together. Perfect. Thanks for clearing that up. And yup, for age 17, rule 1 is the one that should fire. Let's zoom back to decision tables, but now visually. Same nightclub idea, but I'll lay it out as a mini table. Row 1, age less than 18, action, no entry. Row 2, 18 plus age minus 21, action, entry no drinks. Row 3, age being greater than 21, action, entry plus drinks. Column 1 is condition on age. Column 2 is what we do, action. Later, we'll turn each row into Python-like. Row 1, if. Row 2, elif. Row 3, else, or another elif. Before we touch code, if age is 22, which row should be used? Row 1, row 2, or row 3? Age, 22, row 3. That's you already using the decision table correctly. Next, tiny step. I want to show how one row becomes one branch in code. Same table. Row 1, age less than 18, no entry. Row 2, 18 less than age less than 21, entry no drinks. Row 3, age equals 21, entry plus drinks. In Python, row 1 alone would look like, this is literally if the row 1 condition is true, do the row 1 action. Make sense so far? A row in the table, one if, elif, else block in code. If yes, I'll have you help me turn row 2 into Python next. That is such a perfect pick for this topic. Papa Midnight's club is basically one huge decision system. Bouncer brain at the door is doing, are you human, half-breed, full demon? Are you on the list? Are you causing trouble? Each combo of answers, different action. Let in but watch closely. Throw out, block. That's exactly what a decision table captures. Multiple questions, conditions, one clear action per row. Want to do a tiny Papa Midnight Club decision table together next? Then turn it into if, else? Yes, that card test is exactly the kind of thing decision tables are made for. Let's keep it super small and story-like. Papa Midnight's Door Rules, version 1. Condition A, knows what's on the back of the card. Yes, no. Condition B, causing trouble. Now we build a tiny table where each row equals one combo of answers. Row 1, knows card equals yes, trouble equals no. Action, let in. Row 2, knows card equals yes, trouble equals yes. Action, let in but watch closely. Row 3, knows card equals no. Action, do not let in. Notice row 3 doesn't even care about trouble. If you fail the card test, you're out. Does this 3-row Papa Midnight Door Rules table feel clear so far? If yes, awesome. Let's turn that first Papa Midnight rule into code. We had row 1, knows card equals yes, trouble equals no. Let in. In Python, that becomes line by line. If we're checking a rule, knows card equals yes and trouble equals no, both conditions from the row, print let in, the action from the row. Make sense how one row, one if block here? If yes, next we'll build row 2 as an elif under it. Nice. Then we'll stack the next rule under it. We had row 2, knows card equals yes, trouble equals yes. So let in but watch closely. Under the first if, row 2 becomes an elif. Now Python tries row 1 first, then row 2 if row 1's condition is false. Just like going down the table row by row. Quick check. Just think it through or answering words. If knows card equals yes and trouble equals yes, which branch runs? The if or the elif? Exactly right. Those values make the first condition false and the elif true. So the elif branch runs. Now we add row 3 to finish the table. Row 3 rule was, knows card equals no. Do not let in. We don't care about trouble anymore. Failing the card test is enough. As code under what we already have, it would be an else. Here else equals all other rows. In our table, that's doesn't know the card. I'd like you to try this in the code editor now. 1. Open the Python editor. 2. Create variables on separate lines. 3. Then write the if elif else chain exactly like above. 4. Run it once. 5. Change knows card and trouble a couple of times, like yes, yes, no, no, and watch which line prints. Don't submit yet. Just play with run. Tell me what outputs you saw for at least 2 different settings, and which setting triggered each one.